Good morning.
Good morning.
All right. Let's see. Who's here today? All right. So let's see. Um, Looks like is everyone there at Joseph City? Oh, we're missing Rebecca.
And Taylor.
Yeah, Rebecca and Taylor are gone.
Thank you. All right. And we missing anybody in Holbrook?
Everyone's here.
Naomi.
Oh, wait, what?
Naomi.
Naomi's not here.
Okay. All right. Wonderful.
Oh.
Okay. So let me just a couple of things before we get started. This is especially for my Holbrook students. If you want to email me about this class or reopening a quiz or something like that, make sure you use my MPC email, not my Holbrook email, because when I'm going through and I've got I kind of use my MPC emails as a checklist to make sure I get things done and follow up and everything on the Moodle. And so a lot of times I don't double check. And so I noticed this morning in my Holbrook email, there was a couple emails from you, but see, then I don't, when I'm teaching my Holbrook class, I don't have the college stuff open. Does that make sense? So it just makes it a lot easier for me if you would just email me on my MPC email. So if you would do that, that would be great. Okay. Let's see. So did anybody do anything amazing over the weekend? Well, let's see. I guess, Lauren, you did the sound for Matilda. That was good. It wasn't, the sound wasn't distracting, and you didn't notice it that much, which is, I think, what you want, right?
Yeah, thank you.
So that was good. Anybody else do anything amazing?
I bought clothing and shoes.
Oh, I went to INFR.
You went to where?
Las Vegas for Indians National Finals Rodeo.
Oh, okay. Well, so that's pretty cool. So were you in it?
No.
Did you compete?
No.
Yeah.
Just
Well, I know a few years ago, Holbrook had a rodeo club, and there was a guy that I can't remember his name, but did really well in the rodeo circuit or whatever. So that's pretty awesome. Anybody else? Okay. Well, let's just talk for a minute about I'll because we have some people gone, I'm going to mention this again tomorrow. So we do have our midterms coming up. So this Wednesday and Thursday from 11 to 12 is when the parts will be open. you will have the midterm. Now, you only get one attempt for each part, okay? But it is open book, open note, and there is the 1 hour time limit, okay? So you don't get extra time or whatever. So you've got to make sure you want to be ready, start on time, to use up the time. Like I said, it's open book, open note, but it is only one attempt. Okay, now, so a couple of people have told me that they've got a PSAT that morning or something, and wanted to reschedule part one. A couple people on Friday, a couple people Wednesday afternoon. I'm willing to work with that, but again, you need to whenever you need to reschedule something or schedule a retake or a second attempt or something, please talk to your talent aid first to make sure that they can do it. Okay, so we had a situation last week where somebody asked for a time and I go to set it up and realize that the talent aid is not going to be there during that time. So please do that first. Okay.
How many questions will the midterm be?
I think it's 20 questions on each part. I'll double check and I'll give you a more complete breakdown. I was going to do that today, but I think well, let's see. I might know for sure. 20 questions for each part. Okay?
And then I don't know if you can tell us this or not, but is there any part of the test that, like, is there anything that the test goes over more than others?
No, because, I mean, there's a lot of material and there's only 20 questions. So chances are nothing's going to be hit hard. Okay? I mean, really, let's see.
Yeah, because like for the chapter 1 test, like there was 1 or 2 questions per section maybe for the test, but then there was like 5 or 6 questions that were all complex fractions.
Right.
So there was
Oh,
there were more of those than anything else.
So there were more than anything. Yeah, I would say then, Lauren, probably then that was a test that I got from the department head. Because I'll tell you, when I do a test, what I try to do is to cover as many topics as possible, but not the most difficult part of each topic. Does that make sense? So I try to do sort of a medium level difficulty, or even easy, but I try to cover as many sections as possible. So what I would suggest, and I used to be pretty good at this. By the time I was like a senior in high school, you learn the different teachers and how they come up with tests. And yeah, it is kind of weird with me because sometimes I'm using the department head's test. But typically when I'm doing something like a final, I will go through section by section. And I'll say, okay, if I were going to ask one question from 1.1, what would that one question be? And then I go to 1.2. And so then I go through all the sections and then go back through it again, as far as I can. So typically, like part 1 isn't necessarily going to be harder than part 2. And it's not like part 1 is on chapter 1, part 2 is on chapter 2 or something like that. I try to go through the whole thing and then go through it, then as I go through the second time, then I'll say, okay, what do I think if I was going to do a second question from 1.1, what would that question be? So that's kind of how I design it. So anyway, let's see. So I guess, okay, so I guess we got this I can post. Okay, so So just a reminder, it covers chapters 1 through 3.3. It's open book, open note. So there will be no broadcast on Thursday because you'll be taking and we normally don't have one on Wednesday, but there won't be on Thursday. So the midterm, so we'll have it Wednesday and Thursday, 2 parts, 20 questions each, 1 hour for each part, 1 attempt. And then after the midterm with the curve is posted, so I think I talked about this last week, but I am going to curve the midterm based on all my Math 152 students. But then once that's posted with the curve, so chances are that's probably going to be Monday morning is when I will post the curve. And so all grades up to that point are locked. Okay. So there's not going to be no more second attempts, no more retakes. If you haven't taken a quiz at that point, it'll just become a 0. Okay. And then, so the next class after the midterm will be next Monday. Okay. All right. Any other questions about that?
I have a question. So, do you know which chapters are going to be on which part?
Okay, what I just said earlier is it's not divided like that. That what I do is I go through, and so the part 1 is going to be chapter 1 through 3.3, and part 2 as well. It's just going to be, part 1 is going to be the first question that I pick from each of those sections. Part 2 will be the second question I pick from each of those sections. So both of them will cover chapter 1 through 3.3. And I'm not saying that part 1 is harder or part 2 is harder. I actually think last year there was, I think maybe the curve came from part 1. That there was like a 5-point curve, and it was from part 1. So I think at least based on last year, it seemed like part 2 was easier. I don't know, but a lot of things from last year aren't the same as this year. So we'll just see how that goes. Okay. Any other questions on the midterm? Okay. So if you haven't started doing like the tests in the book, you might do those for practice. Okay. And so after each chapter, so you do the one after chapter 1, the one after chapter 2. Make sure you do some problems from chapter 3. And I'll tell you what I'll do is I'll kind of budget some time tomorrow. So before I go over any new material tomorrow, what I will do is ask if there's any questions on your review. So if there's any problems that you'd like me to work, all I ask is, and I don't mind doing that, although I see our class time is very valuable, and I'm willing to do that as long as you've tried the problem first. Okay? I don't want to just do problems for you. I do that all the time. So, but if you've attempted a problem to review for the midterm and you're stuck, you don't know how to do it, then I would like you to ask me tomorrow at the beginning of the class, and we'll go through that. Okay? All right. Well, let's go ahead and get started. So today we are on 3.4. We're on practice 2B. And remember, this material is not on the midterm, but it will be on the final. And of course, the 3-4 quiz and the chapter 3 test. All right. So let's go through this. I think I don't know, did we start this practice problem at all or not finish it, or did we not start it at all?
We did that one and we're on practice 3.
Oh, we're on practice 3?
Yeah.
We were supposed to finish it that night.
Okay. Okay. Okay, got it. Okay, let's just. I was looking at the wrong thing there. Okay, so it says z varies directly as the square of x and inversely as y. If z is 36 when x is 6 and y is 7, what value does z have when x equals 12 and y equals 21? All right, let's see how we did on that. So let's go with Tara. So were you able to finish that one? Get an answer?
No.
No. Okay. Well, let's go through it here. So first of all, you set up the formula. Okay. And so I guess we did that. Then next, you go to the comma here. So you say, because you're trying to solve for k. So you plug in 36 for z. Oh, where did I put it? Oh. So so then you plug in 36 for z, 6 for x, and 7 for k. All right. Did anybody get k? Anybody go through it? Avery, what'd you get?
I got k equals 7.
K equals 7. Let's see. Yep, there we go. K equals 7. All right. Then it says, what value does z have when x equals 12 and y equals 21? And so then, you plug in those values into your original formula, as well as 7 for k. Okay. So you want to substitute in 7 for k, and then you plug in 12 for x and 21 for y. And then you can just crank that out. Anybody have a final answer for us? All right, Jill, what do you have?
I got z equals 48.
Z equals 48. Yep. That's it. So there, after you solve for z and plug that into the formula, then it sort of becomes a plug and chug type problem. So, okay. Any questions on that? All right. All right, next, multivariable functions. So it says the force of gravity F between two objects depends on the masses of the objects and the distance between them according to the formula. F equals K m sub 1 m sub 2 divided by d squared. Okay. So kind of based on what we talked about earlier in this section, then the force varies directly with the two masses and inversely with the square of the distance between them. Okay. Now, I remember when I first studied physics in college and we came across this formula that I was just blown away with the fact that you use the same formula when you're studying the force between two planets as you do when you're studying the force between two electrons or something. It's the same formula. And so gravimetric force and let's see, I guess it would be nuclear force, is the same thing. I mean, it's just the different scale. Anyway, it kind of blew me away. Now, here, the constant K is already determined for you in this situation. If you're talking about the gravity, the universal gravitational constant, K, what we do is replace it with G for gravitational constant. So it's 6.67 times 10 to the negative 11th. Okay, so that's just one example here in the real world in physics where we use, again, this is joint variation. So we have direct variation and inverse variation in the same formula. Okay, all right, so let's look at the practice problem here. It says the volume of a right circular cylinder varies jointly as the height and the square of the radius. All right? So see if you can write that formula. So just from that first sentence. All right, Desiree, what do you have?
I need some help.
Okay, so if we say it varies jointly, then that means it's just going to vary with more than one variable. So if it varies directly with the height, okay, then you would say volume V equals K, the constant of variation, times the height, which we can use X or H or whatever, okay? And the square of the radius. So that means it's another direct variation. So you have another variable. And so you would write that as R squared. So it'd be V equals K times H times R squared. So it varies jointly. So that means there's more than one variation going on here. Now, sometimes if it's direct or if it's inverse, then it'll say inverse, and then you would put that in the denominator. Okay? All right, so express this relationship in equation form and find the height if the volume is 30 cubic inches and the radius is 5 inches. Okay? Well, what are we missing here? I mean, well, let's go back. If we want to find the height, so we'll find H. If the volume is 30 and the radius is 5, well, what are we missing here? What have we been able to do up to this point that we're not able to do here? All right, let me say it a different way. In solving these problems, the first thing we did was write an equation.
Okay.
What?
Find K.
Find K. So we're not given information to find K. So how do we do this problem? We don't know K. Or do you know K? From your vast geometric knowledge.
Don't you replace it with G?
No. That was in the last problem. The
Say
G
it.
was.
Wait, why is that
for-
pi?
The what?
Pi?
Say it again? It's pi. See, this is the volume of a right circular cylinder. See, in the last one, we were told what G is. And this one, we know the formula for the volume of a cylinder is the area of the base times the height. Well, the area of the base is pi r squared. So in this problem, you're not told information to find K, because you're expected to already know this one. Is in this one, K is pi. And so we don't have to find K. It's already pi. Okay, so now see if you can finish the problem. All right, Jill, when you've got it.
I got H equals 0.382.
There you go. 0.382 inches. So you could have it as 6 over 5 pi, or if you wanted to do as a decimal, 0.382 inches. Would anyone like me to go through that?
Yes, please.
Okay. So you have the formula, V equals pi r squared h. So it's telling you that V is 30, R is 5, and we want to find h. So then you plug in 30 for V. So 5 squared is 25. So then to solve that for h, you divide both sides by 25 pi, and you get h equals 30. Divided by 25 pi. 5 will divide into each of those, so 6 divided by 5 pi, or 0.382 if you put it in your calculator. Now one thing I would remind you, when you're putting that in the calculator, you need to put parentheses around the 5 pi. Because otherwise, if you do 6 divided by 5 pi and no parentheses, then your calculator will just do 6 divided by 5 and then times pi. And so you'll get the wrong answer. Okay. All right, any questions? All right, well, that's it for 3-4. All right, so now what we're going to do is start in on 3-5. Now, again, 3-5 is not going to be on the midterm. So except really, okay, I was just about to say a lot of this in this section is a review of graphs and transformations that we've done before. It's just now we're writing them in function form. And so a lot of the graphs and transformations are on the midterm. It's just we're kind of looking at them in a different way as functions. Okay? So shifting, reflecting, stretching graphs, symmetry. Okay? All right. So this is a good review of a lot of the graphs that we have studied so far. Okay. So this is kind of the summary of the graphs of parent functions. Okay. So let's see. Okay. So the first one, linear, where we have a line, f of x equals ax plus b or mx plus b. I've kind of divided it into two parts, two special ones on your paper, on your notes. So the first one is that I want you to write down as linear constant. And then the second one is linear identity. And so these are special types. The linear in general is f of x equals ax plus b, but the ones that have names that we use a lot are constant, and that's f of x equals a constant, so that's just a horizontal line with a zero slope. And then linear identity is y equals x, or f of x equals x. And so that goes through the origin, and then whatever the x value is, the y value is too. So 1, 1, 2, 2, 3, 3. So it goes through at a 45-degree angle. So linear constant and linear identity. Okay. All right, next, number 3. It has a lot of names. You can call it a squaring function, quadratic, or you could even call it a parabola. The parabola is really the name of the graph, whereas the squaring or quadratic is the name of the function. F of x equals x squared. So that's the U-shaped curve. And the parabola can open up or down for the function. Okay? All right, the fourth one is the cubic function. And so the cubic function is f of x equals x cubed. And that's the one that kind of goes up and levels off, passes through the origin, and then goes up. That's the cubic function. All right, number 5 is the square root function. That's the one that starts at the origin and then goes up just in one direction. F of x equals the square root of x. That's the one I call the car hood because it looks like the front end of a car. All right, number 6 is the reciprocal function. So that's f of x equals 1 divided by x. So this one has both a horizontal and a vertical asymptote. And so that since this is a rational function, odd, positive, so it goes up on the right and down on the left. Now, this is a way to describe what's going on in the graph. So when you see these little arrows, it means approaches. You can read that as approaches. So as x approaches 0 from the right, so the plus means to the right. So as x approaches 0 from the right, the y value approaches infinity. And as x approaches 0 from the left, the y value approaches negative infinity. So this is just saying it's going up to the right and down to the left of the vertical asymptote. All right, number 7 is the greatest integer function. So that has the brackets around the x. And so this is a type of step function where it looks like a staircase. And just remember that for each little step, you have one side of it that usually on the left side is where you have the closed dot, and the right side is the open dot. But you cannot, remember the vertical line test. If you ever draw a vertical line and you have closed dot over closed dot, that's bad. That means it's not going to be a function. Okay? All right, and then finally number 8, y equals the absolute, actually we're doing this in function notation, so it should be f of x. No, let's just drag this over. And we're going to just say f of x equals, so we're in function notation, the absolute value of x. And so that's the V shape where the vertex of the V goes through the origin. Okay. All right, so any questions on those parent functions? So my expectation there is that you know what those are called and you know the basic graph of the parent function. So if I say the absolute value function, you should know that's a V shape that goes through the origin. Okay? So that's my expectation. All right, then the types of transformations of these parent functions. Okay? Shifting, stretching, shrinking, reflecting. So again, we've done all this before. We're just haven't done it in functional notation. All right. So now what I would like you to do on your student success organizer on practice 0, it says give the name of each function. All right, so see if you can do that. So just write the name under each of those 8 graphs, little graphs there. All right, so Anna, what do you have for the first one?
Linear constant.
Linear constant. That is correct. Okay. Was there a question on that one? All right, Serena, how about the second one?
Linear identity.
Linear identity. Excellent. All right, Kinsley, the third one.
Absolute value.
Thank you. Good job. All right, Jocelyn, the fourth one.
Square root function.
Square root function. All right, Serena, the fifth one.
Quadratic function.
Quadratic function. All right, Jill, the next one.
Cubic function.
Cubic function. Very good. Avery, the next one.
Reciprocal function.
That is the reciprocal function. And then finally, the last one, Jill.
The greatest integer function.
That is correct. And so, and it's an example of the step function. Okay. All right. So, any questions on any of those? Okay. Now, again, my expectation is that you know these parent graphs, okay? But let me just tell you that most of these are in the front flap of your book, okay? So if you forget any of that, okay? Avery, are you listening to me? Okay, front flap of the book, okay? All right. Okay, now let's go back to talk about the transformation. So when we're doing, let's see. So when we have a horizontal, well, actually, so when we do the horizontal and vertical shifts, the tricky ones are the horizontal ones, okay? Because like here, if I take the square root function, when it's inside the function, the shift, it goes the opposite way. So when you have a -2 inside the function, it moves the graph 2 to the right. When you have a +2 inside the function, it moves it to the left. So the horizontal ones are the tricky ones, okay? So like here, this is going to shift the cubic function. So when you're trying to graph these or just look and see which graph matches, you say, okay, the parent graph is the cubic function. And then this is shifted to the, which way?
Left.
2 to the left. And so instead of the midpoint of it going through the origin 0, 0, which point would I want you to graph exactly on the graph? Instead of 0, 0, I would want you to graph
Negative 2, 0.
negative 2, 0. Okay? That's the point you would want to have. All right, so this one, the parent graph is what? Absolute value. And then this is shifted which way? 4 units to the right. So instead of the V going through 0, 0, it goes through what?
4, 0.
4, 0. Okay? So, when we did these in chapter 1, okay, again, if this would be a perfect example of why you might struggle with finishing a test or the midterm, is if you had to look this up instead of saying, oh, this just shifts to the right. Okay, you can do this problem in 5 seconds. Whereas if you have to look it up and figure it out, see, that's okay, but you better not have to look up too many or you're not going to finish. See what I'm saying? So you've got to study and work it through. Don't think, oh, just because it's open book, I don't need to study for the midterm. Okay? You'll be horribly mistaken if you have that attitude. Okay? All right. So the vertical shift upward is when the number that you're adding is positive and it's outside the function. Whereas downward is just negative, but it's outside the function. So the vertical shifts are when the number's outside the function at the end. Okay, the horizontal shifts, left and right, are when the number is inside the function and then it goes the opposite direction that you think it will. All right, so I would like you to now do practice 1, A and B, and I would like you to just kind of do a rough graph by hand. Don't use your calculator unless you want to check it. But I want you to try to do it in your head. All right, so Jay, what's the draw for me in the air what the cubic function looks like?
He said draw. I'm not quite sure.
Okay.
The cubic is
So-
like that, right?
Yes, that was one of the 8 that we started with. So it goes like this. Okay. All right. So I guess like this. Okay. So Jay, what does the +5 at the end do?
It moves it up 5.
Moves it up 5. Very good. And what does this one? How is this one shifted?
See, that's where I get confused on this when all this stuff comes in. And so the plus
Right.
2, does that mean to the right or up and down?
Okay. The +2 outside the function means it's shifted up 2.
Okay.
The -3 inside the function, that's a horizontal shift. So that's going to shift 3 to the right.
To the right, because
Yes.
this is lie.
Yes. Right. So what you do, so here's the regular cubic. And so this one is shifted up 5. So instead of going through 0, 0, the point that I would want you to have dead on accurate is the point 0.05. Okay? All right? Now, the second one, again, here's the cubic. And so then this is shifted to the right 3, 1, 2, 3, and up to 1, 2. So that point right there, 3, 2, that's the point that I would want you to have graphed exactly. Okay? Everything else, we're just faking it. I mean, we're just doing the best we can. All right? Okay? All right. So does that help, Jay, or do we need to do some more examples? What do you think? You're good? Okay. So now again, the calculator, graphing utilities, so calculators, computers, whatever, are great to double check. Like if you're not sure, okay, does this go to the left and the right? I remember asking myself those questions. Which way is it shifting, up and down? Well, you can use the calculator, okay? But again, every time that you reach for it, you're probably going to lose a minute at least. So you need to kind of minimize that kind of stuff. But it does help you. Okay? All right. So graphing calculators are ideal tools. All right. So let's see. So this says, all right, let's say you had a squaring function that shifted down 2. What would be its equation? All right. So, well, the squaring function is y equals x squared, but then down 2, so minus 2. Okay. All right, so see if you can do practice 2. So you're writing the equation this time. Oops. All right, so Tara, when you've got it.
Is it f of x equals parenthesis x plus 8 parenthesis cube take away 3? Or
I think that's what you said, isn't it? Okay.
yeah.
All right, great job. Great job. Any questions on that? All right. So, all right, so another type of transformation is a reflection. And so what causes that is the negative. So when you have a negative outside the function, it reflects it through the x-axis. When you have a negative inside the function, then it reflects through the y-axis. And I think that's a good place to stop right there. So we'll do the practice tomorrow with that. All right, any questions, comments, concerns before we drop out here? All right, well, you guys have a great day. Come with questions tomorrow, and we'll do a little midterm review. All right, have a great one.